And welcome back to part 7 of CNC lathe programming. In this lesson I'd like to talk about the constant service speed that's used on a CNC lathe. I'm going to introduce 3 new G-codes: the G96, which sets the cutting speed, the G97, which sets RPM, and G50, which limits the RPM that your CNC will turn. Alright, then we'll talk about the benefits of using constant service speed, and I'll show you a couple of formulas to calculate RPM and service feet per minute. Alright, so let's take a look at an example of a part that has many different diameters and how the RPM changes to maintain constant service speed. Alright, so for this part, the tool manufacturer has recommended that we use 600 service feet per minute. Now, as you can see, we have several different diameters. We're starting out with a 1/2 inch, and it climbs up to 1 inch, 1.5 inch, 2 inch, and 2.5 inch. And we're actually starting with a 3-inch diameter stock. So at each diameter, you can see maintaining a 600 service feet per minute, or constant service speed, we would start out with an RPM of 4,584 RPM at a 1/2 inch. Then it climbs up to an inch diameter, and at that point we are at 2,292 RPM. Then it slows down again as we climb up to 1.5 inch, and we are at 1,528 RPM. And then at 2 inches we are at 1,146, and at 2.5 inches we are at 916 RPM. So you can see it would be hard to determine just an RPM that would work for all of these diameters and expect good tool life and good service finish. Now, instead of doing that, just tell your machine to maintain a 600 service speed, and the machine will automatically adjust for all these diameters. So let's talk a little bit more about why to use constant service speed. Alright, so the benefits of constant service speed would be that it simplifies the programming. Now you don't have to determine what RPM to program, because you just set the constant service speed and the machine will automatically adjust the RPM depending on the diameter it's cutting. So it also produces a consistent service finish, because the feed rate and the constant service speed work hand in hand to produce a constant service finish. Alright, and it also optimizes the tool life, because the RPM is not too fast or too slow, which would in turn increase tool life. And then lastly, it optimizes the machine time, because the cutting conditions will always be set properly, and that translates to minimal machining time. Alright, so let's take a look at a program and see where we put all these codes. Alright, so here we're looking at the program of the finish pass of the part we looked at earlier, and let's talk a little bit about the format here. So we have made a tool change right here, picking up tool 101, and then the first thing you want to do is turn on the spindle with a constant RPM using the G97 command. So when you turn on the spindle at S1500, no matter what diameter the tool is at, it will always spin at 1500 RPM. Then you wrap it into position, getting ready to do your finish pass, and at that point the first thing you want to do is set the G50, which is limiting the RPM. Now that's going to depend on the size of the part. Now a part this size, you probably don't want to spin faster than 3000 RPM, but some of the smaller parts that you will be running, you could max out at 5,000 or 6,000 RPM, or whatever your lathe will allow. Alright, so then after you limit the RPM, you set your constant service speed using the G96 command with the recommended service feet that the tool is rated for. Alright, so that is how simple it is to let the machine determine all the RPMs at all the different diameters. Alright, so let's take a quick look at how we calculate RPM and service speed. Alright, so the first formula I want to talk about is that for calculating RPM. So we take the constant of 3.82, multiply that times the service feet per minute, and then divide it by the diameter that you're turning. So in this example, we're going to take the 3.82, multiply that times a surface feet per minute of 600 that was recommended by our tool manufacturer, and we're going to be turning a diameter of 0.750. So if we plug those numbers into the calculator, we take a 3.82 multiplied times 600 and then divided by 0.750 diameter. We get an RPM of 3056. So that's a simple one. Alright, so then there's one more, and that is for surface feet per minute. So let's take a quick look at that. Alright, so to calculate the surface feet per minute, we take the RPM, we multiply it times the diameter that we're turning, and we're dividing it by the 3.82 constant. So for our example, we got the constant of 3.82 and an RPM of 2200, and we're turning a diameter of 1 inch 750. So let's get the calculator back out and plug in those numbers. So we got the RPM of 2200. We're going to multiply that times the diameter of 1 inch 750 and then divide that by 3.82 equals 1007 surface feet per minute. Alright, so these are a couple of formulas that will come in handy for calculating your feet and speeds when writing a program. Alright, so let's talk about one more thing, and it is when not to use constant surface speed. Alright, so there are a couple of operations where you do not want to consider constant surface speed, and one of them would be drilling, because the RPM would max out because you are drilling at 0 diameter. So even at 1 surface feet per minute, you would max out your machine RPM. And then there is threading. Threading requires perfect synchronization between spindle revolution and z-axis motion, so it is not capable of maintaining constant surface speed. Alright, so that's all I have for you on constant surface speed. Thank you for watching, and I hope to see you in the next video.